So as we just discovered, the highest density value is right around 10. So for this control range, this is again the range of density values in our voxels. Let's set the maximum to be a little bit more than that at 11. So that way, basically the 0, which is no density, is over here, has none of the effect. Once we reach the highest amount of density, we're at 11. Now we're at the full effect of this gas disturb. In general, I always like kind of modifying this ramp a little bit. So I think something maybe around there would be cool. That just breaks it up even more. So let's have that. And then let's also check out this block size. This block size is basically how big are the holes going to be when this noise goes to do its thing. So to figure this out visually, the easiest way is to create a box like that. And this is something I learned from Stephen Nipping's Applied Houdini, which is a great course if you haven't checked that out as well. He does an excellent job teaching this stuff. If you go to this uniform scale and we say 0.3, that is basically how big the holes are going to be when this gets punched in the smoke. If I set this to, let's say, 0.1 or something even less than that, 0.05, I think that this is going to work much better for the scale that we're trying to get. The disturbance does really well when it comes to fine details. And I think that this is a good size to start at. So let's say 0.1, or did we say 0.1? 0.05, actually. We'll say 0.05 on this block size. And then I'm going to create one more disturb over here, and I'm going to set this to a relative reference of this. So copy this parameter, paste relative references, and we'll go for about a third of that size. So times 0.33. And that way we have just a couple of levels of detail, and that will be very nice. Let's also create relative reference on this amount, like so. And for this disturbance, I'm going to start off by turning this way up. So let's say a disturbance of 1. And now as we play forward, it's a little bit difficult to see right now, but we are beginning to break up these density values a little bit within the smoke. So you can't really see it that well, but once I bring everything back, it's going to be very obvious. So let's actually bring these other effects back and go forward a few frames, and you'll see it really clearly. Okay, and there we go. You could see it especially once the smoke or the steam starts evaporating towards the edges there. You could see it just has a lot more breakup, and right now it's too much, but you could see that it is working. And when you turn the resolution up, this will be even more obvious and will have a lot more detail. Okay, so this disturb, let's turn this down. I think 0.25, so a fourth of this effect is probably going to be the right amount. You don't want to do too much of this because otherwise the smoke looks too fuzzy and weird. So just a little bit is usually fine. All right, and there we go. Now we have something like this. You might have to mess around with the dissipation values. I think I actually paused the video and changed that. I was being sneaky. So in your scene, you might have to turn up or turn down this dissipation a little bit. But in general, that seems to do the job just fine. Last thing on this disturb is that you can also use this with velocity, and that will work pretty nicely in most cases. So if you decide to use velocity, you can just say vel, and you need to check this disturb field as a vector field. And then that will also kind of push things around in space with velocity. And just to give you an idea of what that looks like, this is generally what happens when you affect velocity instead of density. It's all personal preference. You can even do both. So one way to do this is that we can be doing the same exact thing, plug these two in, and now change this to density. In the next video, let's start wrapping this whole project up by introducing a little bit of wind and then moving on to shading and rendering.